Greetings, everyone, and thank you for participating in this seminar. Thank you, Marco. So, as we look at some of the events that have happened in the past year and looking forward to 2025, Agentic AI and its evolution has been one of the most pronounced initiatives that we see. We're going to take a look at some of this progression and some use cases and some of the Next 25, which is Google's yearly conference, wave of agentic AI products, and taking a look at AI in action. As we look at some of the trends in the past and looking what's going on now, a lot of pioneering research and development in artificial intelligence has been what Google has been engaged in, as we see the transformer architecture and all the way of evolution towards the Gemini models. If we reflect on one of the recent developments, after DeepMind produced AlphaGo in 2016 and was able to defeat the world champion, AlphaFold was the next offshoot of that project, in which an input is given to the language, to the model, which is an amino acid sequence of protein, and an output of a three-dimensional structure of protein folding is produced. This allows us to make significant scientific breakthroughs in chemistry, drug discovery, clinical trials, etc. And for this, they were awarded the Nobel Prize in Chemistry this year. Demis Hassabis and John Jumper were awarded this prize for this AlphaFold achievement, which allows us to go beyond what one scientist can do, and it empowers a scientist to be able to visualize different 3D molecular structures. This is an example of the innovation. Another one of the innovations has been GraphCast, which is the ability to forecast weather at a new degree of precision and specificity. These are examples of innovation. And as we look towards the evolution and anatomy of agentic AI, the current state of the art is very focused on pattern recognition, very niche expertise, and multimodal processing. There's domain-specific areas of focus, such as for AlphaFold, or etc. Lots of efficiency gains. We've recently seen a resurgence or a starting of thinking models or reasoning models. Gemini 2.5 Pro is an example of that. They have enhanced planning, reasoning capabilities, creative problem solving, and they have the ability to have a sophisticated world model. They have a notion of how the world functions and provide their reasoning capabilities or planning capabilities based on that. This enables us to build agentic systems even at a higher level of scale, because these agentic systems, these multi-agent systems, require very strong planning and reasoning abilities and a very sophisticated world model. As they're executing tasks, these tasks need to be monitored. And as we move towards autonomous operation, from human in the loop to semi-autonomous, and then as we gain comfort and validity and verification that the agents are doing their jobs properly, and the ability to stop them when they're functioning inappropriately, we can move certain non-risk items into autonomous operation or more of autonomous operation. This also requires negotiation and coordination between agents. We are actually on the brink of, we can see the horizon of artificial general intelligence, which is human-level cognition and creativity. This requires extremely complex reasoning, accurate world models, a notion of how the world functions, the physics in the world, how things are related to one another, spatial dimensions, geography, those types of things. And of course, historical precedents, so long-term memory is required. This is actually a precedent to what we might term artificial superintelligence. And this is not any science fiction or Star Trek kind of situation. It's really about surpassing human cognition and allowing a scientist with a co-scientist to produce revolutionary scientific breakthroughs. And in doing so, world-shaping potential is there in these types of breakthroughs. This essentially allows us to extend biological limits that we have. However, scaling of data and compute alone is not sufficient to achieve things like artificial general intelligence. There are other breakthroughs required. There are issues around questions around safety, deception prevention, and ethical development that are critical and need to be researched and established. But AI agents are really a very cardinal moment for the transition from the current generation of thinking models to AGI. As we look back over the past couple of years, 5 trends stand out. I'm going to cover trends 1 and 2, which has to do with multimodality of AI that unleashes the power of context, and AI agents moving from traditional chatbots and assistants to more of semi-autonomous multi-agent systems. And in doing so, I have to mention 3 other trends. One is that of assistive search. So a generative search that combines information and provides a new frontier for knowledge work by combining different sources together rather than just listing URLs. Another trend is to take a look at how generative AI can impact the user interface and create hyper-personalized experiences. And lastly, but actually more important than all of these, is the security that is required and is much more tougher now with AI. So AI in the hands of bad actors could mean less security, therefore efforts to bring security to AI and AI to security, enabling security to leverage the capabilities of artificial intelligence in order to provide more optimized functioning. So as we look at it, a notion of centralized intelligence in one model is moving towards distributed intelligence on behalf of the workforce. So we have human in the loop today that can check actions, and we can move gradually towards autonomous operation, where agents can perform complex tasks and workflows with minimal human intervention. This requires sensing the environment, whether it's digital or physical, reasoning and planning. Agents can leverage advanced AI models to make informed decisions and adapt to changing environments. As they do so, they need to learn from experience and from humans who are performing human-in-the-loop reinforcement learning and improve their performance, improve their understanding of what is aligned with human values over time. Also, as we have multiple agents distributed, these agents need to learn to work together to achieve shared goals and unlock new levels of complexity and efficiency. So you can see the movement from chatbots to assistants to agents with humans and gradually moving in the direction of autonomously getting work done. So if we were to depict this, that one central intelligence of an LLM can now be distributed into multiple agents with humans in the center. But as we move more closely towards semi-autonomous agents, because we are able to trace and track and monitor and evaluate the performance of these agents, and could they be positive, then we can remain in the loop, but have more of a supervisory capacity. We can be a reference for approving or double checking controversial situations where human intervention is necessary. for conflict resolution or consensus between agents. If we take a moment to look at what agents are, this is a blog that you can find if you Google my name and agent anatomy, that you will find this on Medium. It is describing how you provide in Agent 1 a set of instructions, and these instructions are provided as goals for the agent. And the agent can sense its environment, whether it's digital from a database or knowledge graph or vector database, or an actual physical environment in a manufacturing plant as a robot or with sensors, IoT devices. And take these inputs and reason about them using its language model. And then coming up with a plan. And these plans are a series of steps, series of actions it might nominate to take. They may need to be coordinated with other agents or with humans. And then eventually, they need to take action using tools or APIs that allow the agent to perform activities. Sometimes these agents may have to interoperate with other agents, thus these lines between Agent 1 and 2 and Agent 1 and 3. And in other cases, they may need shared memory to share common outputs so that as they collaborate, they can pass information back and forth. So as we see this technical evolution going from LLMs and prompting to LLMs and retrieval augmentation, getting data, putting it in the context window, and eventually enabling the LLM with tools so that we detect an intent as the LLM detects the intent and chooses which API to call as a set of tools. And this may be going in a loop of reasoning and changing the planning that it needs to be conducting in order to produce the outcome. And gradually, as we scale up, we have many of these, which are multi-agent systems. However, taking agents into production is non-trivial. We are chasing quality of the output from these agents, from their LLMs, or small language models for that matter. There are an evolving landscape of regulatory and compliance requirements. There's sometimes unpredictability of the results, and so on and so forth. So in an effort to support these various important aspects of going into production, enterprise-grade, production-grade, agentic AI, at Google, we recognize we're entering this new era of AI innovation, where there's multimodality in thinking models, there are agentic workflows, and there's a knowledge frontier of how employees, and coupled with AI, can find information, access information, and interact with it. So if we take a look at some of the use cases and the impact across industries, we can see that agents are part of a new system design. As a software system that can get things done on behalf of users. As we discussed, this shows planning and reasoning, memory, and some degree of autonomy to make decisions, to learn, and to adapt. We're seeing organizations gradually get more sophisticated with these use and design of these AI agents to accomplish tasks. And some of these tasks are essentially building customer agents, employee agents, supercharging the design process for marketing and sales, assisting with writing, personalization, marketing campaigns in creative agents, being able to perform complex data analysis and unlock new ways in which we do data science via prompts, essentially, and having data science agents do some of the work for us. This allows us to code better and faster and just test the code. So AI-enabled code generation and assistance for code completion is a trend. And of course, strengthening the security posture within organizations and for individuals by mitigating threats or attacks and increasing the speed of investigation, mitigations, and recommendations. So managing the agent lifecycle and the growing agent ecosystem interactions in a multi-turn, meaning multi-interaction, multimodal, meaning text, audio, video, sound, code, is part of an agent-to-agent interaction that's extremely critical. And it is fundamentally transforming how organizations across multiple industries actually operate. In retail, there's digital experiences and customer support and marketing optimization that happens. In healthcare, as we discussed, drug discovery, clinical support, and disease diagnosis. Financial services allows us to do financial service advice more effectively, perform risk management effectively, and customer service more effectively. I obviously can't answer all the questions, but I saw just one question pop up. Why do we call these agents? This is a very classic term in computer science. It isn't a new thing that we just invented, in the past couple of years. I've been teaching artificial intelligence and machine learning for many years, and this is something that has been in the literature for 20, 30, maybe 40 years. Back with Minsky at MIT, and so on. And we can obviously talk a lot about that. But they have agency, meaning they have the ability to do things on behalf of us, and thus the anatomy of agents that I went through. If we look at a very specific area of financial services as an example of a use case, the payments value chain. This is a very complex essentially workflow and a chain of multiple actors and interactions. So if we take this process, there's an acquisition, there's a network, there's an issuer where the payments are issued. There are many incumbents and disruptors who are leveraging AI and agentic AI in order to disrupt and enable the creation of value in this supply chain, all the way from the merchant acquiring the information or the product to clearing and settling the transaction, and an actual card issuer issuing, authorizing transactions, detecting fraud, processing the transactions, issuing statements, etc. At Google, when we develop AI, we're very focused on responsible AI. We have a set of principles that are used to safeguard the input into actual models. And as we process inside the model, making sure bias is not there, controversial issues are balanced and not skewed in one direction or other. And the output is also verified and checked. And we have one of the most interesting capabilities, which is factual grounding. So even after you generate content, you can ground that in either your data within your organization, or within Google Search, or within third-party partners such as Moody's or Thomson Reuters or ZoomInfo, where they are companies that have canonical, well-established, credible sources of information, let's say around companies and a registry of companies and their financial statements, etc. So if we look at some of the differentiators, some of the additional differentiators, we just mentioned this grounding, long context window and multimodality. We've been pioneers in this area of 2 million context windows. This enables us to input tens of thousands of lines of code, over 1,400 pages of PDFs, 2 hours of video, etc. And this allows us also to build something we call the Multimodal Live API. This enables us to speak directly to the language model. And you can see these on your phones that are enabled with Android and devices that have Gemini Nano on them. These are cost optimized, and you basically can replace, to a large extent, the context window with what you do in retrieval augmentation. Although retrieval augmentation is also important, you can consider this. You don't have to do embeddings because the embedding is done automatically. If you choose this path, although we have retrieval augmentation and vector databases as well, for those who would like to continue using those techniques. And we have the ability to distill models. And there's lower data movement because you can actually bring AI to data. And for example, from BigQuery, directly invoke the Vertex AI capabilities that are the platform for AI with Google. And then, of course, with Agentic AI, which we'll talk about. And all of this secured in the VPC-SC secure parameter context. At Next, we've announced our agent platform. One of the applications we announced is Google Agent Space, which we'll get into. This is a portal to do enterprise search and access agents, such as our deep research agent, an idea generation agent. There's an integration with Notebook LM and Chrome Enterprise, and there's an agent gallery in which third parties can produce agents, and they're discoverable in Agent Space. And in Agent Space, you can specify connectors to backend systems within an organization, consolidate that information, and bring it to users. We've also an open source agent development kit and an agent engine, which is a runtime, and an agent interoperability protocol, or agent-to-agent protocol, which allows communication of agents between enterprises. Specifically in Vertex AI, we have an agent garden where you can discover pre-built agents to jumpstart your development. Okay. And you can essentially deploy AI agents at an enterprise scale with confidence. You can deploy agents that are built using any agentic framework with enterprise-grade controls for compliance and security and safety and logging, session management, evaluation capabilities. And we'll get more into that. In Agent Space, you have an agent gallery, and we support partner agents, agents that you build and put in that agent gallery. There's a Chrome Enterprise extension for search that's available. And we have an agent designer that lets employees create custom agents with a no-code builder. In Agent Designer, as a productive employee, you can automate the business processes you're undertaking and tasks you do by using a very simple chat-based interface with multiple pre-built tools and actions with no code required that also support the open agent-to-agent protocol. And there are two new Google-built expert agents. One is the deep research agent that uses Gemini's multimodal intelligence to help employees conduct research and take all these different data sets, combine them into rich, actionable insights and reports. And the ideation agent helps employees generate meaningful, impactful, value-added ideas in a very interesting way, where a tournament is created between agents and an LLM as a judge is utilized to critique these agents and rank them in terms of which is the most viable one. This calls for having a clear vision and strategy and a disciplined execution capability in order for agentic AI to succeed in your organization. Because we're navigating unprecedented complexity and yet opportunity. It does represent a paradigm shift, and we're moving beyond simple automation or prediction to systems that can actually reason and plan and act to achieve complex goals and work together as different agents, collaborating with one another. This actually introduces a new level of complexity. As we said, deploying agents in production is not a trivial task. And you need capabilities, you need expertise, you need know-how. Also, we want to ensure that there is alignment and focused investment because agentic AI can be resource intensive, requiring significant investment in talent and data infrastructure, in model development or access and ML ops. And of course, we need to be mindful of having a governance around agents that basically oversees the ethical risks, the security risks, the operational risks, such as financial loss, reputation damage, or system outages, making sure they're minimized or eliminated to whatever extent possible, and their compliance risks when handling sensitive data or operating in regulated industries. This planning and clear vision allows us to accelerate innovation and realize business value because the AI field is moving at a very, very fast pace. And this allows organizations to quickly iterate, to learn, to reassess, reposition themselves, pivot, and have a significant advantage. This allows us to sustain that competitive advantage because agentic AI is not just about efficiency. It's also about creating fundamentally new value propositions, very personalized experiences, and deeply fundamentally intelligent products and services. So let's look at this next wave of AI agentic development. So if you look at the different personas that can leverage and customize agents and build them, you can have business users on the one hand, leverage agent space from Google, or conversational agents for the contact center. As a developer, you can use the agent development kit and deploy anywhere. And if you choose to deploy it on a managed service, we have the agent engine as the runtime. Or you can choose to build open source or from scratch and then deploy on agent engine as a managed service. And of course, these are options you have as different personas within an ecosystem. So let's now take a look at this architectural construct here, where we have applications like Agent Space, Agent Designer. The Customer Engagement Suite is a contact center set of applications built on top of the Vertex AI Agent Builder for developers. This has the Agent Development Kit, which is open source, the Agent Runtime, which is a managed runtime, and an Agent Garden, where you can leverage agents that others have developed or Google has developed. You can run them on Gemini or any of the 200 models in the model garden that we have, leveraging the capabilities of data, of Google Search for grounding and RAG, and hundreds of connectors, millions of customized APIs, knowledge graphs, and workflows. So if we take a quick look inside the Agent Development Kit, you have a flexible framework, open source, for developing and deploying agents. You can integrate them with popular LLMs and open source generative AI tools, but there's a tight integration with the Google ecosystem and the Gemini models as well. So if you think about this in different levels of abstraction, Agent Development Kit is at level 3. These are things like Crew AI, AutoGen 2, Open AI, Agent SDK. These are at level 3. You can either build everything from scratch at level 0, or have low-level LLM frameworks like LangChain, or build on top of that with LangGraph. And then on top of everything, you have these no-code platforms such as Agent Space. So these are some of the levels of abstraction of building agents. The Agent Development Kit itself provides a framework and a software development kit to build multi-agent solutions. So you can orchestrate these agents, as the example is showing. There's a route agent, a flight agent, and a hotel agent, which helps you book appropriate flights and travel. There is a UI, as you can see on the right, a developer UI, so that you can iterate fast and visualize the agent topology and trace the agent's action. So the logs of what the agent has done. And Agent Space is in GA and available, by the way. I see some of these questions pop up. So if it catches my eye, I'll just comment on them quickly. Also, with the Agent Development Kit, you have the ability to combine deterministic logic in a workflow with more non-deterministic workflows like function calling. And you can integrate that with GenAI reasoning to build hybrid agents. This is also enabled through the enterprise capabilities we offer, which involves long-running synchronous tools, long-running memory, and the interaction with humans, with human-in-the-loop interactions. Even though Gemini is the default, you can use any generative AI model to support your agentic workflow. And we support the invocation of remote agents and thousands of existing tools via the Model Context Protocol, which helps you discover resources within your organization. For example, take this supply chain monitoring agent. It has a few agents that it oversees, a news agent that looks for disruptions in the market, geopolitical event, new news around tariffs, new news around weather events, etc., things that can potentially impact the supply chain, and a procurement agent that leverages something like SAP Ariba or Oracle Fusion, and an inventory agent that uses a supplier agent to perform its tasks. There are various tools in the Agent Development Kit. We have function tools, we have pre-built tools, third-party tools, agents as tools, or MCP tools, tools that essentially abide by the Model Context Protocol. And of course, tools from Google Cloud. So in this multi-agent system, for example, you have in this, this is an example taken from our GitHub repository, one of the many 12 examples that we have in the GitHub for Google /ADK-samples. So there is for example, a story team where there's a researcher, a writer, a titler, and a file writer. And in this case, the system is trying to build stories for, let's say, TV shows. So with the ADK, you have many types of capabilities that is available. As we mentioned, a UI, support for evaluation of agents, callbacks, so that when an agent has completed something, it does a callback to invoke functions through the flow. There's session memory for stateful conversations, and there's collaboration on documents with shared artifacts. And you can deploy this to the agent engine runtime or your own fully managed agent infrastructure. This allows you to have agents collaborate easier with one another. You can create custom tools, or you can import LangChain and Crew AI tools. You can evaluate agents easier, and you have access to session memory for stateful applications with easy communication between agents. We also have the live streaming API when you build with the ADK, so that you can communicate directly with your LLM. So in terms of some of the ADK concepts, we have the concept of a base agent and an agent in general. The base agent can be extended by an LLM-based agent or an LLM agent. This allows reasoning tools, transfer of delegation of responsibility or actions to another set of agents. And we have workflow agents. Some of them are sequential, so you have a set of agents that do things in sequence, or parallel agents that can operate in multiple different threads, and a loop agent, which allows you to iterate over tasks and exit a task when a certain condition has been arrived at. And then you have custom agents, which combine these together. So a custom agent can basically leverage decision points, can call subagents or tools, process the result, perform an action in a loop. So you can combine the sequence, the parallelism, and the iterations into a custom agent. Now, you've built your agent, you want to deploy it. One of the options is the agent engine from Google, which is on our Vertex AI platform. With this, you can develop and customize, deploy, serve, and manage any kind of agent, whether it's our ADK built agents or we support LangChain, LangGraph, Llama Index, AG2, Crew AI, all these open source AI agents, including the open source ADK from Google. And the Vertex AI engine, being a runtime, allows you to have access to your agents, scale up and down based on the compute needs of the agentic multi-agent system. There is inbuilt security and authentication, and you can be framework agnostic. One of the most important things is to be able to monitor these agents, to understand the behavior of the agents with open telemetry integration with Google Cloud Trace or third parties like Weights and Biases, Arise, and Langsmith. We also have the ability to measure the quality of the work done by the agents through the Vertex AI evaluation service and to improve agent performance with an example store and optimized with the Gemini training runs, which are developed for agentic AI applications. There are also advanced tools, some of which is available now, some of which are in private preview, and some are coming soon. These are the code execution sandbox to run agent code, agent simulation to proxy user traffic so that you can enable agent evaluation and monitoring better, and computer use by agents. So essentially being able to, as a human, you're going to a website, clicking somewhere, copying and pasting from somewhere into another application. You can teach agents to do these kinds of things repetitively and construct an agent to do that in agent space today. So looking at our models for a second, we have over 200 models in the Vertex AI model garden. They consist of first-party models like the Gemini models, Imagine, VO2 for video generation, Lyria for music generation, and other third-party models from open source, open weight models, such as Llama, Mistral, Anthropic's Claude, AI21 Labs, Jambo, etc. And our own Gemma family of models, which are the smaller models that are open weight models from Google. So we have our first-party models, which are Gemini. We have our open weight models, which are Gemma models. We also have third-party models and open models, such as those from Anthropic and DeepSeek, etc. And we have new models from various places like Allen Institute, Cam.ai, and Kodo. Let's take a quick look at our Gemini 2.5 family. So 2.5 Pro is actually in preview right now, and it displays top of the leaderboard capabilities in math and science, in reasoning, in developing code, generating code, and in agentic applications such as agentic coding. It has surpassed the state-of-the-art performance on benchmarks such as LM6 Arena, Live Bencher, etc. And it shows very strong code improvement capabilities. As users have noted, it is the strongest model for many of their tasks for coding. It has up to 1 million context windows, with 2 million coming soon, has a high accuracy and retention rate, and an increased output token limit of 64K. It has the ability to reason because it's what we call a thinking model, and it understands multimodality. So you can give it an audio transcription, or ask it to perform an audio transcription with a long duration, speaker labels and timestamps, understands images, and can generate images. So in terms of content understanding, Gemini supports state-of-the-art multimodality and document understanding. Its large context window allows you to put in large numbers of documents from all different modalities and process information fast. You can extract and summarize long documents. You can enrich your multimedia catalogs. You can transcribe audio recordings. You can analyze videos for insights or highlights of the video. And of course, you can tune and customize your model with your own data. So whether this is a very simple, cost-effective redesign of the prompt using our prompt optimizer, or doing supervised training or parameter-efficient fine-tuning, and with distillation of the Gemini models. And you can do full fine-tuning with the open models on Vertex AI. So we talked about the Agent Development Kit agent runtime, which is Agent Engine, and some of the models that can be used to power that. Let's take a look at Agent Space. You can build agents with ADK, deploy them on Agent Engine, publish agents to an agent marketplace, and surface those agents in the Agent Space's Agent Garden effectively. Let's take a look at some of the Agentic AI in action. So we're introducing Google Agent Space, and this is really the only hyperscaler as Google with a platform that's built to help enterprises adopt AI agents at scale and also effectively improve employee productivity. So as we introduce Google Agent Space, we're thinking about democratizing AI and providing access to deep research agents that helps break a complex task into its chunks of manageable steps that are executed in a planned sequence. There's an ideation agent that is an AI-powered innovation engine for the enterprise that does idea generation. And it does so in a very interesting fashion. So it generates ideas, and for each of the ideas, let's say it generates 50 ideas. For each of these, it assigns it to an agent. And there's an LLM as a judge, let's say Gemini 2.5 Pro. It has a dialogue with each of the agents and critiques the agents for the ideas, probes them to defend their ideas and provide like a Shark Tank kind of business case for their ideas. And it helps rank these agents by the LLM as a judge. And eventually you get a ranked list of detailed innovations with an agentic system that has brainstormed ideas and has evaluated them in a tournament style with user feedback. So that's one of our agents, the ideation agent. And we have a couple of research projects, Project Astra and Project Mariner, which I'll talk about Project Astra later. I'll show you a demo, which is basically exploring the future of interactive or a universal AI assistant. And what we call Project Mariner, which is an action framework that understands and reasons across everything on your browser screen, the pixels, the text, the code, the images, and the forms. So inside of Agent Space, you can do search, you have an assistant, and you have Notebook LM Enterprise. So it acts as a hub for agents, whether they're first-party agents from Google or third-party from our partners in the enterprise space. So this allows you to find agents in the Google Cloud Marketplace for various types of expertise in different areas. And Agent Space has a number of connectors to over 100 types of repositories and databases, whether it's SAP or Salesforce or Box or Jira, or Google Drive, Google, Gmail, Google Search, um, Outlook email, SharePoint, etc. One of the things you can do as a portal within your enterprise is have a people search with an embedded experience, with a highly interactive view of the organizational chart for your company. We've integrated Notebook LM, which is a very popular free tool that we have, into an enterprise context. So there are regulatory and compliance and data regionality constraints that exist, and we've added them in the context of agent space into Notebook LM. So you can add notebooks as context within an agent space assistant, and notebooks become a searchable source like any of your other backend connectors. And it is included, these notebooks you generated are included in autocomplete suggestions. And you can still generate the very popular podcast style of interaction from these notes. Coming soon in second quarter of this year are data loss prevention, federated search, where you can have search and agentic capabilities without indexing the data for a subset of connectors like ServiceNow, Slack, OneDrive, Outlook, etc. And you can bring your own model in Q3 of this year, where it doesn't have to be the Gemini model, it can be any model in the model garden. Every such institution which has a portal would like to see, the most popular questions, user retention, and what are the features that people use, what are the queries, what are the prompts they give, what are the actions they take. So you have an analytics dashboard that can give you deeper insights into the usage, the quality, the performance from an admin perspective. You can obviously generate video and images here as well. There are content recommendations, like you have a feed with recommendations and notifications, personalized content for different departments, different roles within the organization. There's also a no-code builder that we're previewing, which allows every employee to create their own custom agents with a very simple chat-based interface. And you can automate very common tasks using over 30 tools and actions that are built into Agent Space. I mentioned the live streaming API, so we have this in preview in second quarter of 2025, where we include AI conversations that feel interactive, so you speak to it versus typing. The next demo that I'm going to be showing you is this Project Astra. So you can build Astra-like agents with Gemini and the Google ADK. This is a project called Project Pastra, which combines the Google ADK, and it gives you flexibility and ease of control to build these types of agents. So this is an example of a colleague of mine who's interacting with this project, where he's showing specific types of earbuds and getting support for a specific type of return or phone, and having Gemini answer questions based on the multimodality here. I also would like to show you another version of our Project Astra. I don't know if you can enable sound here. I think the sound is not enabled for this conference, but I can voice over it. So basically, this is using a phone and interacting with Gemini directly and asking what is this object here. It says it's a speaker, and asking what specifically is that part of the speaker, and it's called the tweeter. Then it goes to creating an alliteration, like a poetic version of what it sees. So this is showing multimodality, and it creates the alliteration. Next, it goes and points at code, showing the additional multimodality capability, and says, what is this part of the code doing? And it says it defines encryption, decryption functions. So it recognizes code as well as images and real-world objects. It next goes to show its knowledge of the world and the complex worldview that we talked about earlier. It asks what part of what area this is, and this is the King's Cross area of London, known for railway stations and transportation connections. And then it asks Gemini, do you remember where I put my glasses? And Gemini says, yeah, I remember. They're on the desk near an apple. So then our colleague puts on the glasses, the Google Lens glasses, and then can have the same experience with these glasses. What can I put here to increase throughput and performance? You can add a cache between the server and database that could improve speed. What does this remind you of? It reminds you of Schrodinger's cat. And then finally, the fun part, wants to create some kind of a combined word for these two, and calls them golden stripes. So this is the type of capability which demonstrates essentially the multimodality and reasoning capabilities that we see. So live streaming, which is direct interaction, multimodality, deep reasoning, human interaction, and the ability to take actions on our behalf. So the next demonstration I'm going to show you is going to be the data science agent. And the data science agent is available in the Agent SDK, the Agent Development Kit. And in this case, the idea is to define a data science agent that can access BigQuery, call the data science agent, and load artifacts from the BigQuery. So it wants to execute a BQML code, check the model, get a RAG response, and call the database agent. So here we're showing the integration with the UI and showing what the multi-agent definition looks like, and how we can run different kind of natural language to Python analysis with this capability. So this essentially, with a prompt, you can generate a plot of, let's say, total sales over time. The data set is called the Iowa Liquor Sales Database, which provides, it's a static database from a pedagogical perspective, and it shows how it can utilize the data science agent. So here it's showing that it's called the data science agent. There's a response that came back. It's loading artifacts, and then effectively the question is plot the total sales over time using the data from the previous query, and it's showing how the output of one has resulted in the output of the total sales. And it says, okay, I have the plot of total sales over time. Here's the result. Here's the explanation. The data science agent was used to retrieve the total sales for each date from the train table. And the data science agent was able to generate a plot of total sales over time using the data it retrieved from the database. And this plot shows a trend of total sales at various dates and how it varies with the provided data. And you ask it, now plot the sales per product, and it goes back, calls the database agent, and plots the sales for each different type of product. So with this, what sense you get is the ADK developer UI gives you the ability to essentially interact with the development UI in a conversational interface, and it can effectively invoke agents. In this particular case, it is the data science agent that is being shown here, and in interaction with BigQuery and loading. This is actually a time series regression model with the AMER algorithm, and it demonstrates how it processes information as a data science agent and essentially help you as a co-scientist perform your work if you're a data science person, or you're aspiring to perform certain tasks that a data scientist would do. This can augment your functionality by having a data science helper. These span things like new table creation, new models like the ML forecast model, and performing left joins, etc. So then you can also evaluate the model that was created with the ML forecast. And it shows the interaction between BigQuery and your data science agent. So this gives you the ability to see that you have multiple development paths. You can build agents, the agent development kit, you can deploy it on Agent Engine, and you can even surface that in Agent Space. The agent has models, and these models can be Vertex AI prediction endpoints, and you can also access them through a variety of mechanisms in the model garden. In Q3, we're going to have Project Astra implemented in Agent Space and computer use agents with Project Mariner implemented in Agent Space. So you can so you have agents that can complete tasks on your behalf using the browser or your computer via the Google DeepMind's Mariner technology, and seamlessly integrate that into your browser and into Agent Space as an assistant. So in a multi-agent world, it's important that agents can talk to one another and interoperate with one another, regardless of who has developed an agent with ADK or with LangGraph or with Crew.ai or with AutoGen 2, they should still be able to talk to one another. So each vendor has its own framework. Siloed agents are coming out from vendors. We need opaque agents that cross organizational boundaries. But if you have opaque agents, they're not sharing tools, they're not sharing memory, they're not sharing thoughts or plans. So it's difficult to represent agent as a tool given the multimodal, unstructured nature. So open API specs or MCP aren't sufficient for these types of activities. We need a new protocol where we've introduced the agent-to-agent protocol. It's an open protocol that's specifically designed to handle the dynamic and multimodal nature of how agents should collaborate, let's say, across boundaries. It's designed with production-grade enterprise use in mind, So you have security and governance embedded in it. And it's built on top of popular standards like HTTP, SSC, or JSON RPC. And you can now interact between agents across multiple organizations. We have over 50 partners who have contributed and are endorsing and utilizing the agent-to-agent protocol. I think we're out of time right now, and would like to thank you very much for all your engagement, the great questions,